In the chemical reaction that we're going to look at, sugar, C6H12O6, will react with potassium chlorate, KClO3, to give KCl, CO2, and water. The question that I'm asking is how many grams of KCl will be produced? So if I put in my labels, I want to know the mass of KCl that's going to be given up. Let's say I start with 2.183 grams of sugar and 3.421 grams of potassium chloride. I can't easily tell with those numbers what the limiting reactant is. It's not like the other example that we've seen where there's an excess and we know that one is going to be product determining. So before I even start doing any math, let's balance the chemical equation. Okay? Let's start by balancing carbon. So we've got 6 carbons here and 1 over here, so we'll need 6. Then let's look at hydrogen. I've got 12 and just 2, so I will need 6 hydrogens. Then oxygen appears a number of times, so we're going to come back to that. Potassium appears once, and chlorine once, and once. So let's check my oxygens. On the reactant side, I've got 6 plus 3, that's 9. Over here I have 12 plus 6 is 18. So the easiest way to get to 18 would be to multiply the chlorate by 4, and then we can adjust the KCl. So I could have multiplied this by some number, but then I'd have to adjust carbon and hydrogen, which would have me adjust these coefficients, which would then throw off oxygen again, so we'd be back and forth, back and forth. So by changing the coefficient here, I adjust oxygen on the reactant side like I need, and then since KCl appears over here all by itself, I can just place a 4 in front of that pretty easily. Now what do? We hop on that mole train. In order to do that, I'm going to need my molar masses. 180.16 grams per mole for sugar. So I can take the mass, 2.183 grams of sugar, and divide it by the molecular weight to get moles of sugar, and this comes out to be 0.012 moles of C6H12O6. And we'll do the same thing for the potassium chlorate. The potassium chlorate mass is 122.55 grams per mole, and that calculation is going to look like this, where we divide again by molecular weight and get moles, 0.0279 moles of KClO3. So I'll plug that in here, 0.0279 moles. So do we know what the limiting reactant is yet? No. We haven't carried out the mole ratio to determine how much product is going to be produced given this amount of sugar, given this amount of potassium chlorate. So I prefer, since we are looking at a yield of a particular product, is to say, well, how much potassium chlorate can I produce with this much sugar by using mole ratios? So I have 1 mole of sugar making 4 moles of KCl. And that math works out to be 0.048 moles of KCl. In the case of potassium chlorate, I'm going to take 4 moles of potassium chlorate and react to give 4 moles of KCl. So this will of course, cancel out the units, and my 4's cancel. So I can make 0.0279 moles of KCl with the amount of potassium chlorate that I have. So remembering the definition of limiting reactant says it's the reactant that will be completely consumed and determines the amount of product that you can make. So I only have enough potassium chlorate to make this much KCl. And so the potassium chlorate then is my limiting reactant. And I'm just going to write that up here and circle it, saying that that's my limiting reactant. It will determine how much product that I make. So all of this will be consumed, and we will be left with 0 moles of that reactant at the end of the day. And then KCl, we would produce 0.0279 moles and be left with 0.0279 moles at the end, since we started with 0 of all my products. So in order to get from moles to mass, again, we'd have to take and use the molecular weight. So the molecular weight of KCl is 74.55 grams per mole, 0.0279 moles of KCl, multiplied by 74.55 grams per mole, gives me 2.08 grams of KCl. And that is my final answer that was asked for. So we were able to take masses that we started with, find moles, hop on the mole train, use mole ratios to find the amount of moles of product produced, and the limiting reactant was the one that produced the least amount of product. And from there, we were able to take moles to mass and get the answer that we were asked for. Thanks for watching.